Welcome to this online training about creating a system design with Platform Designer. My name is Steve. This training is available for desktop viewing, as well as in a format compatible with portable devices, both available from the same link included in your registration email. For either version, while watching the training, use the controls at the bottom and side of the screen to navigate to any point. Feel free to pause the training at any time to experiment with the software. When you are done with the training, please use the link provided in the registration email you were sent to provide us feedback on the training and ways in which it can be improved. I'll remind you about that later. By the end of this two-part training, you will know the basics of how to use the Platform Designer user interface to create a system design for implementation in an Intel FPGA device. Along with this, you will see how Platform Designer fits into the Intel Quartus Prime software design flow as another method of design entry. Part 1 focuses on getting familiar with the tool and the basics of its use when starting a system design. In Part 2, you'll learn how to finish building a system and incorporate it into an Intel Quartus Prime software project. When you're finished with Part 1, be sure to proceed to Part 2, linked at the end of this training. If you're not familiar with what Platform Designer is and its capabilities, check out the separate Introduction to Platform Designer e-learning, linked here. Before we get started, it's important to understand that there are two different versions of Platform Designer, depending on whether you are using the Intel Quartus Prime Lite or Standard Edition or the Pro Edition. Platform Designer is identical between the Lite and Standard Editions, so let's compare this version with the Pro Edition. When using the Standard Edition, you work with a .qsys file to create your system. The .qsys file contains all the information required to generate RTL code for the system, including all component connections and IP and interface parameters. In the Pro Edition, you still work with the .qsys file, but the file only contains component instantiation and connection information, just the information required to generate the interconnect fabric, essentially turning all components in the system into black boxes that hang off the interconnect. In the Standard Edition, anytime you change any system or component parameters or connections, the RTL code for the entire system must be regenerated. This can take some time with large system designs. In the Pro Edition, component information is stored in separate .ip files for each component. A .ip file is created for each unique parameterization of a component. So if multiple instances of the same component with the same parameterization are added to the system, only one .ip file is required. Component parameter changes that do not affect the interconnect design can be made in the .ip file, and new RTL code for just the changed component can be generated without regenerating the entire system. In the Standard Edition, every component in the system must be complete and well-defined. Otherwise, the system can't be generated. This includes complete RTL code, completely defined standard interfaces, and hardware.tcl files, or hw.tcl, which are especially required for custom components. In the Pro Edition, components do not need to be complete in order to generate the system. A generic component that defines the interface connections to the rest of the system without a functional implementation is all that's required. This works well for a team-based design, or any system design where part of the system may still be under development. Finally, the Standard Edition interface makes it easy to quickly create, edit, and generate system RTL code. However, with large system designs with lots of components or subsystems, the tool could slow down because the single .qsys file is used for everything. With the change to separate .ip files and updates to the graphical interface in the Pro Edition, the tool still has the same ease of use, but gives you more enhanced control and better interactivity with the design of your system. Platform Designer in the Intel Quartus Prime Pro Edition software is a huge productivity improvement over the Standard Edition. For this online training, the focus will be on the use of Platform Designer in the Pro Edition. However, all the basic functionality discussed for creating a system design is identical between the Lite, Standard, and Pro editions. If you want to learn more about the unique features of Platform Designer in the Pro edition, see the Advanced System Design with Platform Designer online training, linked here and at the end of this training. Let's start with a look at how to use the Platform Designer user interface. To start creating a system design in Platform Designer, launch it from the Intel Quartus Prime Software Tools menu. There's also a toolbar button you can use as a shortcut. You can also launch Platform Designer by selecting New from the File menu. From the New File dialog box, select Platform Designer System File as the design file type to create. If you have an existing Platform Designer system you want to modify, from the File menu, select Open and choose the .qsys file for your system. If you create or open a Platform Designer system design in the Pro edition, it must be associated with a new or existing Intel Quartus Prime software project. This is not necessary in the Standard edition. In the Standard edition, you can add a system design to any project by simply adding the .qsys file as a design file for the project, as we'll see later. You can change the project that the Platform Designer system is associated with at any time using the option shown from the Platform Designer file menu. Use this, for example, after duplicating a system design you want to use with multiple FPGA designs. In the Pro edition, start Platform Designer and select an existing project's .qpf file and the desired project revision if the project has multiple revisions. You can also create a new Intel Quartus Prime software project or revision from here. Note that a .qsys file created in the Pro edition cannot be used in the Standard edition. However, a Standard edition .qsys file can be used in the Pro edition. The Standard edition file will be automatically converted to a Pro edition format when it is opened. So if you want to continue working in the Standard edition, make a backup copy of the .qsys file before it gets converted. Here is an example of the Platform Designer UI in the Pro edition with the main view and tabs visible. The main view of the system is the central tab shown here called System View, which lists all the components added to the system. In the Standard edition, this tab is called System Contents, but it works the same as in the Pro edition. We'll look at this and the other tabs in more detail throughout this section. The Platform Designer UI is a tab-based interface that you use to build and manage your system. The tabs can be displayed or hidden as desired based on the information you need to view and the options you need to adjust. Some of the tabs may appear to provide similar information, but many times viewing the same information in different ways and in different formats can increase your understanding of the system and its connections. The default layout in the Standard edition looks similar but has a couple of different default tabs. All tabs can be displayed by simply selecting them from the View menu. Close a tab by clicking the X in the tab. All tabs are linked together. Performing actions in one tab will affect others, so be sure to check out the many different tabs available to see how they all work together. You can restore all tabs to their default view by selecting Reset to System Layout from the View menu. Click and drag tabs to reposition them. This allows you to customize the user interface to give more prominence to the views you use most often. You can also detach tabs from the main interface to spread them out or place them across multiple monitors. Drag tabs on top of each other to group them, or elsewhere in the main window to utilize display space more efficiently. Each tab can also be minimized or maximized by clicking the icons in the upper right corner of the area where the tab is currently located. While Platform Designer will maintain the current tab layout even if you close and reopen the system, you can save the current layout as a custom layout from the View menu. Use the exported .layout file in a different system design, or create multiple .layout files to create different setups to optimize your workflow. Building a basic system design in Platform Designer involves 5 main steps. First, select the components you want in your system from the IP catalog and configure them using each component's parameter editor. The parameter editors provide a graphical tool for selecting each component's optional settings. Next, use the Platform Designer UI to connect component interfaces to each other. Recall that a component interface is defined as a standard and made up of one or more signals. Platform Designer will only allow interfaces of the same or compatible types to be connected together. Next, for interface standards that require addressing, manually or automatically specify addresses for access by other components. Once you've made the connections and specified addressing, review to make sure everything is valid. All the necessary connections between components must be made correctly in order to implement your design's intended data flow. Finally, generate HDL code files to represent your system so you can include the system in your Intel Quartus Prime software project for compilation. Let's start with selecting and configuring components from the Platform Designer IP catalog. The IP catalog lists the IP and subsystems that are detected by the tool and can be added to your current Platform Designer system. IP are listed under the Library section, and subsystems are listed under the Project section. Any custom IP or components available will also be under the Project section. The IP catalog library is organized by categories to make it easier to find the IP you need. Just expand the groups and select the component that you want to add to your system. To add a component to the system, double-click the IP or select the IP and click Add at the bottom of the tab. You can also use the search field to filter by name. Just start typing in characters and Platform Designer dynamically filters the list as you type. You can also perform general filtering on the IP catalog list using the options that appear when you click the gear in the upper right-hand corner of the tabs as shown. One added feature of the IP catalog in the Pro Edition is the existing IP variants section at the bottom of the list. Recall that in the Pro Edition, a .ip file represents a particular parameterization of a component. The existing IP variants section lists all the .ip files for all the components already added to the system. You can add additional instances of an already added and parameterized component by double-clicking an existing .ip file listed here. Newly added instances must have unique names, but doing this is like copying and pasting an existing component in the system. After double-clicking a component or clicking Add, the component gets added to the bottom of the System View or System Contents tab, and a Component Parameter Editor window opens, allowing you to customize the component for your system design. Each copy or instance of a component added to your system can have its own unique parameterization. In the Parameter Editor, hover over any parameter to see a tooltip for that particular setting. You can see all these tooltips and get access to documentation that provides more details on the component and its parameters by clicking the Documentation button. While the Parameter Editor will prevent you from selecting incompatible settings, be sure to check the Parameterization Messages window at the bottom of the editor to see if there are any issues with the parameters you've selected. Click Finish at the bottom of the window to finish the parameterization and view the newly added component in the system. If at any point you need to change any parameter settings, double-click the component in the System View or System Contents tab. This opens the Parameters tab if it isn't already open. You can also open the original Parameter Editor window by right-clicking a component and selecting Edit Parameters. At the bottom of the editor are Pro-specific options. The IP folder option lets you select where you want to store the .ip file created by this parameterization of the component. By default, this is in a folder with the name of the system placed in a folder named IP in the project directory. The other option, named HDL Entity Name, lets you select the name for the .ip file itself. You can change the file name later using an option in Platform Designer, but do not change the .ip file name manually outside of the tool. There are many different types of off-the-shelf components you can add to your system. Here's a brief look at some of them. The basic functions category includes IP components for managing clock and reset signals entering a system design. Advanced reset components are available for managing multiple reset signals and more advanced control over how the components in a system get reset. Streaming components are used to connect and manipulate the data flows between Avalon streaming interfaces. Memory components include on-chip RAM, ROM, and FIFOs. This category also includes controllers that connect to off-chip memory like flash, SRAM, and DDR SDRAM, as well as on-chip DMA IP, accessible via regular or scatter-gather addressing. Tri-state components allow you to connect to off-chip devices that use bidirectional data buses and to share FPGA pins with common signaling for each of these devices. Bridge components allow you to adjust the topology of the Platform Designer interconnect by inserting components such as pipeline stages, asynchronous clock crossing logic, and logic to bridge the system view or system contents tab. Lists all the components. You can also bridge to other external interface types to the such as JTAG and SPI. This tab is your main interface high-speed interface components, configuring implement the protocol layers needed. Use for this tab to adjust a component's relationship to the rest of the system and interlocking, including its connection to other components, transceivers available in the outside the system to top-level I/O. Finally, or other parts of the Intel components category project includes options for adding processors to your address space, such as the Memory 5 soft processor and the ARM Cortex processors. In the example shown here, found in SoC a number of components, including a clock source component, embedded peripherals, PLL, IP user guide, custom button debounce component, for a more complete and a FIFO of available IP have been added to the system. And details on the implementation and use column of each allows you to enable and disable individual components without completely removing them from the system. When a component is added to a system, a unique default name is selected for it automatically. You can right-click the component name to rename it to something more meaningful. As mentioned, you can add multiple instances of the same component to the system, but each one must have its own unique name. In this system, you can see some of the names: clock, PLL, reset debounce, and LED FIFO. Next, are assigned to many ways available in Platform Designer to connect the component interfaces to each other. When you add a component to your system, the System View or System Contents tab displays all the interfaces for the component. Each interface is a grouping of one or more signals that a component uses to communicate with other components in the system. Most, but not all, component interfaces need to be connected. Some unused interfaces can be left unconnected. This is evaluated on a component-by-component basis automatically by the tool. Component interfaces are denoted using dot notation with the name of the component and the name of the interface. So RGBFIFO.in refers to the agent interface named in that is part of the component named RGBFIFO. Note that unlike component names, interface names are defined by the component and cannot be changed in the standard edition of the tool. The Pro Edition includes features that do allow you to change interface names even on off-the-shelf IP. Again, see the Platform Designer Pro Edition online training for details. An important note is that clocks and resets are considered separate interfaces. Clock interfaces are found on all Platform Designer components and must always be connected to a clock source. Unclocked components are not supported. Reset interfaces are found on all off-the-shelf IP and are synchronous to the clock source used for the same component. Platform Designer does not support asynchronous resets. Reset interfaces should be connected to a reset source. However, depending on the design, you may be able to leave a reset unconnected, though the tool will display a warning. The Connections column in the System View or System Contents tab shows which component interfaces are connected and how they are connected to each other. Use the Connections column to quickly and easily make connections from hosts to agents, clock outputs to clock inputs, reset outputs to reset inputs, sources to sinks, interrupt senders to interrupt receivers, and custom instruction senders to custom instruction receivers. The Connections column graphically illustrates existing connections and the connections that are possible between component interfaces. A black dot indicates that two interfaces are connected. An open gray dot indicates the interfaces are not connected but can be connected by simply clicking on the dot. Hovering the cursor over a dot displays a tooltip of the existing or potential connection defined by that dot. Based on the parameters selected in the parameter editor and the connections enabled in the Connections column, Platform Designer automatically generates its custom-built interconnect. Other graphical details further assist in making connection choices. An arrow pointing away from an interface indicates that it is a host, clock output, reset output, source, or sender interface. Clicking to select one of these interfaces highlights the connection lines from the interface. Black lines indicate a connection to another interface, while gray lines indicate a possible connection. An arrow pointing into an interface indicates that it is an agent, clock input, reset input, sync, or receiver interface. Selecting these types of interfaces, as shown here, highlights in black the connection lines back to whatever interfaces are connected, and possible connections, highlighted in gray. As you can see, the Connections column can become very busy when there are lots of components and connections. You can hide connections by collapsing a component's interfaces. Click the minus sign next to a component to collapse all its interfaces into a single line. Click the plus sign to bring them back. Additional connection and interface filtering options are available in other tabs accessible from the View menu. We'll look at filtering in Part 2 of the training. Every time you add a new clock, host, or streaming sync interface to the System View or System Contents tab, a new column line is created in the Connections column to connect other interfaces to it. With very large systems, the Connections column can become very complicated, making it possible to make incorrect connections. There are many alternate methods for making connections. For example, right-click any interface and go to the Connections submenu. In this submenu is a list of all the valid connections for the selected interface. Interfaces with check marks are already connected to this interface. Click an interface in the list to make or break its connection to the selected interface. Instead of the right-click menu, you can use the Connections tab accessible from the View menu. Select an interface on the System View or System Contents tab. The Connections tab will display a list of all possible connections for the selected interface using a / character to indicate a possible connection between the selected interface and the other compatible interfaces in the system. Enable or disable the connected checkboxes to make or break connections. In Platform Designer, any component interface can be exported out of the system. Exporting an interface brings the signals that make up that interface out to the top level of the Platform Designer system to be connected externally, either to connect to other parts of the Intel Quartus Prime project or directly to device I/O pins. To export an interface, double-click in the Export column for the interface you want to export. A default name will appear in the form of component interface name _ interface name. You can customize the name if you want. The name you specify will be used for instantiating the system design or for making assignments to I/O pins in the pin planner or assignment editor. Once exported, the Connections column graphic for the interface changes from arrows and wires to a directional or bidirectional pin icon to indicate this interface's signals are coming into or going out of the system. To turn an exported interface back into an internal system interface, simply delete the exported interface's name in the export column. Note that a Platform Designer interface cannot be used both inside a system and exported out of the system. This restriction is required for being able to build the interconnect. However, it is possible to do this by connecting the interface to a bridge component. A bridge component, mentioned earlier, essentially duplicates the connected interface, allowing one of the interface copies to be exported and the other to be used inside the system. See the Embedded Peripherals IP User Guide and other training resources listed at the end of this training for more details on the use of bridge components. This concludes the first part of the training. If you'd like to continue the training, you can register for Part 2 for free at the link shown here. To learn about additional resources available to help you with using Platform Designer, continue to the next slide. To learn more about Platform Designer, see the standard or pro version of the Platform Designer User Guide, found with all the other Intel Quartus Prime software user guides at the link shown here. For more information about the standard interfaces supported by Platform Designer, see the Avalon and ARM-AMBA AXI interface specifications. Also, don't forget about the built-in help found in both the Intel Quartus Prime software and Platform Designer. Free self-paced e-learning is available as well. Check out the series of Advanced Platform Designer e-learnings or the additional ones listed here. You can learn details about the standard interfaces supported in Platform Designer and about the unique features found only when using Platform Designer in the Intel Quartus Prime Pro Edition. We also offer a free one-day instructor-led virtual training class that goes into detail on Platform Designer use and includes a complete lab exercise where you get the chance to build and test a system design on an Intel FPGA development kit. Intel offers many options for learning about our FPGA products and for training on their use. The Intel FPGA YouTube channel contains a number of 5-minute quick videos, along with longer, more in-depth training. The Intel FPGA training website is the place to go to learn about our recommended curriculum for every type of user and to register for a class. While there, you can register for over 300 e-learning courses, just like this one, made up of narrated slides presented in an interactive player. You can also register for one of our full-day instructor-led training classes taught by experienced training engineers, either in person or virtually over the web. All instructor-led courses have hands-on lab exercises to practice the concepts you learn. If you need further assistance, Intel FPGA provides many self-help resources. Check out the landing pages accessed from the main Intel website that are dedicated to specific FPGA technologies like high-speed interfaces and external memory. Finally, you can also view and post questions to the community forum, monitored by skilled Intel FPGA application engineers. One more thing. When you registered for this e-learning, you should have received a link to a short survey where you can provide feedback. We'd greatly appreciate it if you'd fill out that survey now. We're constantly updating and improving our training materials, and your feedback helps us create the materials that you want. Thank you for your feedback. My name is Steve, and I want to thank you for taking this training about creating a system design with Platform Designer.